Today, we are talking about congruent triangles. Remember what that word congruent means? It means that they have the same measure. So here's a picture of two congruent triangles. We have triangle ABC and triangle XYZ. Notice the congruency marks showing that the corresponding parts are congruent, corresponding meaning in the same position. So here we have angle A is corresponding to angle X. Angle B corresponds to angle Y, and angle C is corresponding to angle Z. When we make what is called a congruency statement, we are stating that one triangle is congruent to another. It is very important that we name those triangles in the same order so that their corresponding parts are in the same position of the name. For example, here I chose to name this triangle ABC. I could have named it CBA, ACB, BCA, BAC. Okay, many different combinations of those three letters. But let's start with triangle ABC. It doesn't matter how I choose to name this first triangle, but whatever order I choose to put those parts in for the first triangle, I must match that same order for my second triangle if I am saying they are congruent to each other. So if I start with triangle ABC, then I have to find the corresponding parts to each one of those. So corresponding to part or angle A is part or angle X. So I have to put the X first in the name of this black triangle. Then I go back and I see what I put second. I put angle B. The corresponding part to angle B over here is angle Y, so it must go next in its name. Then I go to the third letter. I chose C. The corresponding part in the black triangle for angle C is angle Z, so that must go last in my name. So my correctly stated congruency statement is triangle ABC is congruent to triangle XYZ. If I said triangle YZX, that would not be correct. Again, the corresponding parts have to be named in the same order. Okay? So you have to be able to identify the corresponding parts. Sometimes it's real easy when the triangles are oriented the same way, but sometimes it can get a little tricky. So be very careful, slow down, pay attention to the way things look and their matching parts. Okay, so let's do another example here. If I did triangle, say I said YZX, YZX, how would I name this triangle in the same order with the corresponding parts in the same order as YZX? Okay, what corresponds to Y over here? I hope you said B. What corresponds to Z in the green triangle? Angle C. And what corresponds to angle X in the green triangle? It's angle A. So if we're going to say YZX for the black triangle, we have to say BCA for the green triangle. Okay. So triangle YZX is congruent to what? It's congruent to triangle BCA. Let's try another one using the sides. If I have side AC from the green triangle, what side is it going to be congruent to over here in the black triangle? What is the corresponding part? If you were to take these two triangles and lay them on top of each other, which parts would match? What's going to match with AC? you should say XZ. Notice I started with the left side A and went to the right side C, AC. So I have to do that over here as well. XZ is the way I need to name that. Okay, so be able to identify the corresponding parts of two congruent triangles, as well as make a true congruency statement. This is called a congruency statement, putting things in the right order. How do we know if two triangles are congruent? Two triangles are congruent if and only if their corresponding parts are congruent. So all three angles have to match up and all three sides have to match up. It has to be all the parts are congruent. The converse, or the opposite of this statement, is also true. We can say that corresponding parts of congruent triangles are congruent. So if we already know that the triangles are congruent, then we can assume that all the matching parts are congruent as well. And this allows us to make some equations. We can set corresponding congruent parts equal to each other and solve for some unknowns or figure out their measures. This idea is called CPCTC. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. CPCTC. It's just a faster way of saying that. Okay, so let's look at a couple of examples here. A tower's roof is composed of congruent triangles, all converging or coming together towards a point at the top. Name the corresponding congruent angles and sides of triangle HIJ and triangle LIK. Okay, so name the corresponding congruent angles and side. Well, we have three angles. Again, I can take the first triangle and it doesn't matter where I start. We'll start with angle H. So I need to make a congruency statement. Which triangle or angle over here is it going to be corresponding to? Well, I can look at the name here. Look, H is in the same position as the L, so I know that it is congruent to angle L. And I can just keep going in order. Angle I is going to be congruent to angle I because they're both in the middle. And angle J is congruent to angle K because they both come third. Okay, so we're matching them up in order. I can just look at their name. I don't even have to see the diagram. So that takes care of our congruent angles. What about our congruent sides? Again, we just go in the same order. We can say side HI, which is a line segment, is congruent to, now let's go to the other name, and we're going to use the first two letters in the other name. And it's a line segment. So we should put those line segment markings on top of our name. Then we go to IJ. We just pair them up. Okay, so I went to the middle letter and the last letter, so I'm going to go middle letter, last letter, which is IK. And then the last way to pair them would be JH or HJ. Again, the first one, you can pick which way you want to name it, but the second one has to go in the same order. So if I did JH, I have to do KL over here. So for a triangle, if you're comparing or naming corresponding parts, you should have 3 angle pairs and 3 side pairs. So you should have 6 different congruency statements here. Okay. So again, we're just matching the parts and naming in the same order. Here's another example. The support beams on the fence form congruent triangles. Which of the following congruency statements directly matches corresponding angles or sides for triangle ABC and triangle DEF. Okay, so again, we're going to look at the order. So angle ABC, if we went in order ABC, it should be congruent to angle, going in the same order, DEF. Well, this is not in the same order. Has the same letters, but not in the same order. So let's go to the next one. Angle BAC, middle, first, last. So middle, first, last over here would be EDF. Nope, not in the same order. Side BC, middle to last, would be congruent to side EF. And that is not what that says. It says DF, not EF. So hopefully this last one will check out. Side AC, so first and third letter here, AC. So I would need to use the first and third letter over here, DF, and that is what we have. So the correct answer is letter D. Okay, and the last thing is I want you to understand that of our transformations, 3 of them maintain congruency, which means after we undergo the transformation, the size and shape did not change, just the orientation. So if you translate or slide a triangle, are you making it bigger or smaller? No. Are you changing the shape of the triangle? No. You're just moving it to a different location. So the first triangle you had is congruent to the second triangle you had in your new location. Therefore, it's called a congruence transformation. Same thing when you flip or reflect. You're not changing the shape or the size. You're only changing where they are in the coordinate grid. So here I have reflected the triangle, but notice the 2 triangles would still match up if I put them on top of each other. I just have to turn them a little bit. Same thing if I rotate. These 2 triangles are still the same shape and size. So understand that translation, reflection, and rotation are congruency transformations. Okay. The image is still congruent to the pre-image. And that is it for this section. Good luck on your work.